proof by induction then is the third type of mathematical proof that you will have encountered in secondary school at Leaving Cert. The first is proof by deduction, or by kind of logical steps. So that's your theorems. Okay, so just step by step by step proving them. You also did proofs by contradiction. So that root 2 is irrational. You prove that using contradiction. And then proof by induction then is a third type. Okay, the previous two, the deduction and the contradiction, you tended to learn those proofs off. Okay, so that root 2 one you've learned off. It helps obviously if you understand the logic and you can kind of, you know, get there yourself, but you kind of do have some steps to learn off. Same with the theorems as well. There's specific steps they want to see. The induction proofs are a little bit different. There's one kind of that you will learn off, but generally this is just a method that you learn, and then you will be applying it to different problems. Okay. There is a method or steps to follow each time, but you won't be kind of learning off a full proof by induction, as I said, except for one. The three types of problems you will get are proving the sum of a series, so some formula will sum a series for you. There'll be divisibility proofs and inequality proofs. It's the sum of a series one I will start on. And then the one you do need to kind of learn off is the De Moivre's theorem. So I mentioned that during complex numbers that the proof of De Moivre uses induction, so I'll cover that off at the end. But today it's going to be sum of a series. When you're proving by induction, and just to say, sorry, these come up on, well, they tend to come up on paper 1. Okay, they've always come up on paper 1. Anyway, the 3 steps that you will follow when doing a proof by induction. First is to show that some first step is true. Okay, so quite often that is subbing 1 into something and then getting a left-hand side equal to a right-hand side. It's not always 1 that you'll sub in. Sometimes it's 0, sometimes it's some other number. You're going to get that from the question, but you'll sub some number in to show that it's true. Next step is to assume some abstract kind of step is true. Okay, so instead of subbing 1 in and finding that it definitely is true, you're going to sub k in, all right, and assume that it's true. Then, having assumed k is true, you're going to use that to prove the next step is true. Okay, so that might seem a little bit kind of phony or kind of convoluted, that you're assuming this is true and then using that to show the next step is true. But if you kind of think about it, let's say you're proving some step is true if the previous step is true, and you have also shown that the first step is true. So you're showing that any step is true if the previous step is true, and then because you've shown the first step is true, that must mean the second one's true, because the second one's true, the third one's true, because the third one's true, the fourth one is true. So this is like the kind of first domino that you're knocking over. And then these two, I guess, are showing that all the dominoes are close enough to knock each other over. And because you've knocked the first one down, because of this, they will all then follow. Okay? Once you've done those 3 steps, you'll state a conclusion, just that Pn is true. So abstractly, it is true. These will make a bit more sense after you've seen examples, but they're the steps that we're going to follow each time. Okay? First example then I'm going to do is, as I say, a sum of series proof. So prove by induction that 4 plus 8 plus 12 plus all the way up to 4n. So that just means the multiples of 4. So 4n is how you generate these. If you sub 1 in, it's 4, 2 in, it's 8, 3 in, it's 12, 4 in, it's 16, 20, 24, 28, etc. Okay, but if you add all the multiples of 4 together, this formula will do it for you. So this is like your Tn basically. This will generate the terms in your sequence, and this is your Sn. This is your formula which will add them up. So if you sub 1 into this formula, you should get 4 as your answer. If you sub 2 into your formula here, you should get 4 plus 8 is 12 as your answer. If you sub 3 in, you should get 4 plus 8 plus 12 is 24 as your answer. If you sub 4 in, you should get 24 plus 16, 40 as your answer. Okay, so this is your summing formula. Okay, and you need to prove that this will actually sum these together. All right. So as I said, our first step is always just to show that P1 is true. That's not necessarily always going to be 1 you're subbing in. It is in this case. The way to check it is just 4n. If you sub 1 in there, yes, you get 4. Okay, sometimes 0 is another common one, or there might be a slightly higher number, but if you were to sub 1 in there, you get the first term in that series. All right, so their first step is to show P1 is true. So P1, so subbing 1 in for n to the formula, I'm going to get 2 times 1 on 1 plus 1. The first term added together is just the first term, so it's 4. So I know the answer to this is 4 is equal to 2 times 1 is 2 on 1 plus 1 is 2. So 4 is equal, 2 times 2 is 4. All right, so P1 is true. All right, so that's first step done. Second step, as I said, is to assume PK is true. So PK is just subbing K in for n. All right, so on the left hand side, that's going to be 4 plus 8 plus 12 plus all the way up to 4k, and on the right hand side 2k on k plus 1, and that's that step done. Third step is to prove pk plus 1 is true. All right, I'm kind of putting in what my steps are. It's just gonna it's gonna help me get a 10 marks if I do go a bit awry. It's from here that you could find you don't quite get the answer out sometimes. So by kind of having my full steps in and quite clear for the person to see, I'm giving myself the best chance of getting a 10 marks. All right, so k plus 1 is just subbing k plus 1 in for n here, here, and here. Okay, so on the left hand side, 4 plus 8 plus 12. I'm just going to leave a gap there for a second. So I'm going up as far as the k plus 1 step or term on the left hand side. And then how am I going to add that up? Well, I'm going to sub k plus 1 in for n. So k plus 1 for n there, k plus 1 for n there. So don't forget you got the plus 1 as well, another one. The reason I left a little gap here is if you go up as far as the kind of k plus 1 step, then your previous step must be 4k. Okay, so even though you're going one step further, because you're adding up all these consecutive terms in a series, then if you have the 4k plus 1 step, you must have the 4k step before it. Okay, and that's going to be important. All right, so your kind of standard step, the one you'll take every single time with these questions, is in the k plus 1 step on the left hand side, you've got this. Okay, 4 plus 8 plus 12 up as far as 4k. If you look at what you have assumed to be true, you've got that on the left hand side. Okay, in your assumption, you assumed all of this was equal to that. Okay, so this and this is just the same thing. So that obviously means you can sub this in here. Okay, so the right hand side of the assumption I'm going to sub in for this bit of the left hand side in what I'm trying to prove. So instead of this, I'm going to write 2k on k plus 1, and then plus my 4 on k plus 1 that I still have there, and that's equal to 2 on k plus 1 on k plus 1 is 2, so that's k plus 2. Alright, now I'm trying to make the left hand side equal the right hand side here. Okay, so see, haven't done that subbing in. I'm getting closer. Okay, it looks similar enough. You've got just the 1k plus 1 over here. You've got 2 of them over here, but you've got on the left hand side k plus 1 common to both terms. Okay, because it's common to both terms, you can factorize it out. Alright, so I'll go up here to do that. So I'm factorizing k plus 1 out on the left hand side. If I factorize k plus 1 out of this, I'm left with 2k. If I factorize k plus 1 out of this, I'm left with plus 4. And that's equal to 2 on k plus 1 on k plus 2. Okay, and they're quite close now. So the kind of best practice here would be always mess around with the left hand side. Okay, to kind of leave the right hand side as it is and make the left hand side equal the right hand side, rather than kind of messing around with both of them and kind of making them meet in the middle. Okay, now at Leaving Cert, I think you're going to get away with doing stuff to the right hand side as well. Okay, but if you can, I would say just try and tinker with the left hand side to make it equal to the right hand side, rather than kind of at this point maybe messing with both of them to make them meet, as I say, somewhere in the middle. So you would be able to do, if you were to multiply 2 in here, 2 times k is 2k, 2 times 2 is 4, and then they would be equal to each other. And I think you will get full marks for that at Leaving Cert. But if we're to kind of follow the best practice that we should do, make the left hand side equal the right hand side. 2k plus 4, 2 is common to both of those, so I could factorize 2 out. So if I factorize 2 out, of that, 2k divided by 2 is k, 4 divided by 2 is 2. And now you see both sides are equal. I'll just move the 2 out in front so they look exactly the same. Okay, so left hand side equals right hand side, so it's proved. Alright, so you can write LHS equals right, or HS if you want, but just therefore Pn is true, so this formula is true. Is true for all just natural numbers. Okay, so we never these are steps in a series. We never get the 1.5 step, the 2.5 step, or whatever. It's only natural numbers are proven from. That's taken from the question as well. Okay, so that's all your conclusion is. All right. So that's it done in full. As I say, I think kind of solving this one and figuring out what that step is, you'll kind of look back and see this is kind of one of the more straightforward ones you'll do. It is easy enough to get kind of lost in here somewhere trying to figure out how you make the left and right hand side equal. I'll go through a kind of few of the typical tricks, or a few of the typical things it tends to be. in some other examples. But this is where people might go a little bit astray. So just make sure you've got the steps kind of in full, so you'll get all the attempt marks you can.